scalability, true decentralization, and solid security. That kind of in a nutshell defines what we're building with Shardium. It's so if you're already familiar with Ethereum, then it's really easy to understand Shardium, because essentially we're going to have the same functionality as Ethereum does in terms of smart contracts, and then those smart contracts being able to allow lots of other tokens and NFTs and various types of assets. And then then you can also have other smart contracts that understand these types of assets and allow various functionalities, like AMMs, allowing you to convert one type of token into another and so forth. So, whatever Ethereum can do, you should be able to do it on Shardium. Now, the key is that, Ethereum is working towards sharding technology as well, but it's not the same design, right? The sharding part of Ethereum is not the same design as what we've taken in Shard. I'm sorry, the sharding part of Ethereum is not the same as what we've done with Shardium. It's a very different design for how things are sharded. And that, I think, is going to long-term impact things, where, like Ethereum has, I think they're planning for like 64 very static shards. So that'll probably give like a Ethereum like maybe a 50x boost in processing power from where it is now, which would be pretty good. But eventually, as more applications get developed and the traffic increases, you're still going to have this upper limit that you're going to hit, and then now you have to go back to the drawing board and say, okay, do we want to increase the number of shards, or use more powerful computers? How do you deal with it? With Shardium, the problem is already designed into the system. The solution to the problem is already designed into the system. So we simply just add more nodes, and every node that gets added will help increase the transaction throughput. So I do gotta say one thing, like the infinite scalability part, being a technical person, like you know that there's no such thing as infinite scalability, right? I mean, you can't even put an infinite number in a computer, right? There's always a limitation for everything. There's memory limitations, there's storage limitations, there are compute limitations. So nothing is really infinite in the computer world. But I think the marketing team likes to kind of use a word like that because it just kind of makes it easier for people to just kind of have that notion that, oh, this is going to be able to expand to handle more and more capacity. So that's kind of why they put a word like infinitely scalable.
Mr. Umar, from my side, a question was, since Shardius is based on proof of quorum, right? So also you talk about unblocked sharded ledger, right, in the white paper. So
Mm-hmm.
it suspectable to that MEV attacks, because we don't have blocks, so we don't really need to do any kind of auditing. So based on the current development, like, do we have like any scenario of like dealing with MEVs, or like, I don't think like it should be possible, but I just wanted to know it from you, like, what.
So what's the MEV?
Those are like basically when your validator nodes are validator nodes, for their own gains. So it's minimum minor
Oh, yeah,
expectable
yeah.
value, right? So your
Right, the front running
validator can,
stuff.
yeah,
Yeah.
controlling stuff. So there, like
Yeah.
I don't think like I have not like gotten to depth of how like proof of quorum works, but still, since we are using an unblocked ledger, so that is that a like a problem with Shardus too, or like are we trying to solve something like that?
So so the MEV attack can
Mm-hmm.
happen in any network where you have a leader that decides the ordering of the transactions, right? And so, for example, in Ethereum, right? So we don't think of it as Ethereum has any leader, but it does end up having like a temporary leader. So whichever node mines the block or gets to decide what the next block is has temporarily become a leader. And if it generated a valid block, um, it gets a choice of saying which transactions come before which other transactions, right?
Mm-hmm.
Now, typically, even honest nodes, they're not going to be like trying to do anything malicious in terms of the transaction ordering, but because uh, you know uh, in the Ethereum network we allow the the fees that you pay to help to incentivize the miners to order the transactions, that allows this whole MEV stuff to happen. In a network where transactions are ordered based on when the network was seen, or when the transaction was seen by the network, you can't have MEV type of attacks, right? Um, so with Shardium, what we do is we allow the client to put a timestamp on the transaction, and because it's signed and so forth, no, once it comes into the network, it can't be changed by any node, and so we use that, and we require that timestamp to be like within a 1 second window of the current time that the network sees, and so you can try to push your transaction and say that, oh, I generated this a second ago, even though you're generating it now. You can do that, but others can also do that as well. And so you're not really going to gain much by doing that. And if you try to push it too far back, then your transaction will get rejected because it might fall out of the 1 second window by the time it hits the network. So so that's what we're using to order the transactions. And so no node in the network has any say on the transaction ordering. And so that helps prevent, the MEV type of attacks.
Great, thank you.
Hi, this is Devi. Actually, I was reading the white paper for Sardis, and I came across something like every node is assigned a node ID, and eventually each node, a group of node IDs will fall into a particular Sard. So, like, I just want to understand from a transaction request perspective, like, if I am giving a transaction request, how does like it goes into a particular sard? Is there a master node kind of thing, or like it can go to any node and that will redirect it to its ultimate sard?
Yeah. So the way to look at it is, there's the address space of all our accounts, but then each node has a node ID, and the 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 number of bits in that node ID is also the same as the number of bits in the address space. And so you can then think of each node sort of, being somewhere in this address space. And so based on that kind of a topology, um, nodes will cover addresses that are, close by to where their node ID is. And so that is what essentially kind of defines these dynamic shards. Now, the routing of a transaction, the way it happens is, when a transaction hits the network, it can come to any node, but every node knows, all the other nodes that are in the network. So each node has a node list. And based on that, it can route the transaction to the appropriate shards based on the accounts that this transaction involves. And so then, that's how the routing happens.
So basically, each node has the address mapping of all the nodes, not just its SARD's node, but all the nodes in the network.
Yeah, exactly. Yeah.
Okay. Thank you very much.
Mm-hmm.
Can I go for another question?
Sure. Yeah.
Yeah. So as you said earlier, SARDs are driven by accounts, and a group of accounts will fall into a particular group called a SARD. Accounts could be less active, some could be more active, and some could be hyperactive. In a DB world, we have a terminology called skewness, data skewness. So what if transactions are skewed to a particular SARD, probably because of some hyperactive accounts which are there in that particular SARD? So will that be affecting the transactions? It will be making the transactions slower in a particular SARD in comparison to other SARDs?
I think, that is definitely an issue that could happen. And so we don't have like shards that can be like very, very narrow, and other shards that can be more wider in terms of the range covered. So we haven't built technology like that yet, but yeah, and I understand what you're saying. Yeah, that could actually like if you have accounts that are extremely active, that could be a bit of a problem. But if you compare that to a world where if your network wasn't sharded to begin with, and your nodes had to deal with many of those type of accounts, and you still are able to process transactions in those networks, then I think this at least makes it a better situation. Right? So but yeah, ideally it would be good if we could have like a very narrow shard around the really hyperactive accounts.
And does like in such scenarios, auto scaling will come into picture? Like
auto scaling looks at the load across the whole network, right? So if one particular account is getting hit hard, but everybody else is running, the average will not really push it up too much. So yeah.
And my last question, is there a ratio of active nodes and standby nodes? Like, is it at
is there
a ratio of active nodes and standby nodes?
Oh, is there a ratio of how many active to standby nodes? No. That just kind of depends on how many nodes overall the community wants to run. But then the active nodes is kind of determined by Shardeum defining like, okay, we need a minimum of like say 500 nodes, and so and then beyond that, the network can grow based on the load that it sees. But yeah, the ratio, we don't really define a ratio because it would be very hard to maintain something like that.
Okay. Thank you very much.
So simple terms, I think validator nodes is determined by network load, correct? Number of validator nodes determined by
the network load, right? Yeah.
And then number of standby nodes is just how many people in the community want to run a validator node.
Yeah, so standby nodes are actively sending join requests, and when there's some rotation, one of them, might get selected to join the network. Yeah.
A basic question that was just asked the other day
Mhm.
is just, why proof of quorum versus something like proof of stake or proof of work? I mean,
Well, so proof of work, that's just
you don't have to
going to cause a lot of
yeah, you don't have to put proof of work as just out of any consensus
compared to anything else, right?
Out of any algorithm you could choose, why proof of quorum?
It's the simplest consensus algorithm, actually. Yeah. When we do like when a group of people are deciding on anything, we basically use proof of quorum, right? So like, let's say, we have a board committee and we want to decide who the CEO is going to be of the company. And so maybe there's 7 people on the board. We know who all are registered to vote effectively. And then from that, then we can, put in all our votes. The votes get counted, and, based on that, we can make a decision. So that's simply all that proof of quorum is. So in Shardeum and basically Shardis, what happens is, for every transaction, the application layer says, okay, this transaction is valid or not. And then, that gets gossiped to the other nodes, which are part of the consensus group. And the consensus group may be just one shard, or it could be multiple shards, depending on how many different shards this transaction touches. But then those group of nodes vote, and that gets gossiped, and every node then collects what other nodes have gossiped, and based on that, every node can generate a receipt to show that, hey, we've reached a quorum.
Derby Gold Path. Yes, Shardium will have composability like Barnane's Smart Chain and other smart contract platforms because it's a smart contract platform, and that's one of the benefits of hosting applications on the same network.
Yeah, absolutely. And in a sharded network, it gets really complex to maintain composability. Most of these sharded approaches to doing smart contract platforms, what they're going to do is have a shard generate a proof that this transaction was processed here, and then it gets passed to the next shard, where it might need to go through another smart contract, and the whole state of that transaction and everything that's been built up gets passed to the other shard, and then that shard goes and does its processing, and then if the transaction needs even further processing, then it goes and hits another shard, and so forth. And so you have this consecutive handing off of a transaction along with a receipt and data that was generated for that transaction from one shard to another. And so that, it gets really complicated in these kind of scenarios, because you also need to maintain the atomic processing of a transaction, because especially like in networks where when they're grouping these transactions into blocks, but then a block may be rolled back because there was a fork, and so you could have like really messed up situations if the transaction got processed in a block in one shard, but didn't get processed in a block in another shard. And so now you've lost the atomic processing of a transaction. So there's a lot of really complicated stuff that, networks like Near and Ethereum are going to have to do in order to maintain that. The way we do it in Shardus is that we create a consensus group. Because we're processing each transaction individually, we can create a consensus group of nodes that are just processing this one transaction, right? And so once they come to consensus on whether or not this transaction is valid, then it's done and over. There can't be any issues with the transaction not having that atomic processing capability when it goes across multiple shards. Wow. All right. Well, guys, I gotta get going. I gotta take my daughter to a class on Saturday. She goes to a Discover STEM lab, but I really enjoyed talking with you guys. And if you're interested in working on the tech, you have experience with Node.js. TypeScript is also good, but if you're not familiar with TypeScript, it's really easy to learn. But if you're interested in this space, working on this tech, ping me, and we'll see how you might be able to contribute to the project. And once the code is released, everybody would be able to contribute just by reviewing it and submitting issues and merge requests and things like that against it. But while the code isn't completely released yet, if you want to still help out on the team, please ping me. All right, thanks a lot. It's nice talking to everybody.
Thank you so much.
Have a great day, everyone.
Thank you so much, sir.
Yeah. All right, take care. Bye-bye.
Goodbye.